All right, so let's say we want to integrate square root of x times the natural log of x dx. And as with all integration by parts problem, we always start with figuring out what should be u and what should be dv. So in order to make a really good choice, we want to decide what gets simpler when we take the derivative. Or that would be one way of doing it. Another way of doing it would just be, well, we know that we can't take the antiderivative of natural log of x without doing another iteration of integration by parts. So that may not help us very much. This is something that we're not really good at just yet. This is something that requires integration by parts to integrate. So we don't really want to have this be our dv right away. We want to have this be u. We want to have natural log of x be the thing that we take the derivative of and not the integral. So we have a u, and then of course, everything else is going to be dv. So we have u as natural log of x. Du is going to be 1 over x dx, or just dx over x, same thing. And then what we have for dv is just square root of x dx. And I actually want to write that a little bit differently. I just want to write this as x to the 1/2 power instead of square root of x. And then when we integrate that, we get 2/3 x to the 3/2 power for v. When we integrate x to the 1/2, this is what we get. So now we just want to substitute things in where they go. We have a u. U is natural log of x. We have a v. V is going to be 2/3 x to the 3/2 power. We have the same v from before. I'm just going to highlight that one as well, draw a box around that one. And we also have a du. The du we have is dx over x. So now that we have all that information ready to go, we're ready to just substitute things in and then integrate. So we have u, and then we have v. U is going to be natural log of x. And then we have v is going to be 2/3 x to the 3/2. I don't know if you guys are visual learners, but I kind of consider myself to be a visual learner. When I was first taking calculus, I color coded everything, and it just helped me understand things a lot better. So maybe you'll understand things in kind of a similar way to the way I did, but I think it's really helpful to do it this way. So uv, u is in blue, that would be natural log of x. And then we have v is going to be 2/3 x to the 3/2 power. And then after that, we have to do minus the integral of v times du. V is here. And then du is just going to be right next door. Right next door to the v. So what we have for our v is going to be a 2/3 x to the 3/2. And what we have for our du is just going to be dx over x, but I think I want to write this a little bit differently, and it'll be clear why we're doing this in the next step. Instead of making it one fraction, I want to write it as 1 over x times dx. It just makes it a little bit easier to simplify and a little bit easier to integrate, having it as two distinct terms instead of a fraction. All right, so what we have now is natural log of x. I want to move the 2/3 out front. I'm kind of picky about the way my things look. I like to move the numbers out to the front. So we have 2/3 natural log of x, and then we have x to the 3/2. And I typically even like to put the x in front of the natural log of x, but it's not all that important. So we have that as our first term, and then we have minus this integral. I'm going to take this 2/3. I'm going to move it to the outside of the integral. Just makes things a little easier to visualize, a little bit easier to think yourself through the problem. If we don't have anything else we don't need on the inside, just makes things easier. And then what we have left would be an x to the 3/2 divided by x to the first. So what I'm going to do is I'm going to join these two together. I'm going to make them into just one fraction, with x to the 3/2 being the top and then x being the bottom. Yeah, I think I will just, sorry, I'm really picky. I know it's probably not normal, but I'm kind of picky about the way things are arranged. So we have negative 2/3. And then if we simplify this, we have x to the 3/2 minus x over x to the first. So we're going to subtract the exponents. We're going to do 3/2 minus 1, which is the same thing as 3/2 minus 2/2. So this whole thing is just going to turn into x to the 1/2. So now what I'm going to do is I'm going to clear away some of the things we don't really need anymore. We have 2/3 x to the 3/2 times the natural log of x. And then we're going to have minus 2/3 times whatever this antiderivative is going to be. So we're going to add 1 to the power. We get x to the 3/2. And then we're going to divide by 3/2. So we're going to get this times 2/3 in addition to the 2/3 we already have there. So it's going to be 2/3 times 2/3 x to the 3/2 plus c. So this is what we get for our final answer. I'm going to actually combine these. I'm going to make this minus 4/9. 4/9 x to the 3/2 plus c.